Hello students, good evening. So we are in the sixth session of laws of motion and we are discussing the applications of the Newton's laws. Okay. So we have been looking at different arrangements of the objects, and if there is a case of unbalanced forces where the objects will be having acceleration, we are trying to look at different scenarios in that. Okay, already we have covered some models and we are going to cover the next set of models in this session. Okay. So we'll start with the session. So we are in the applications of the Newton's laws, and we were looking at the different set of possible arrangements where we can study the Newton's law application. So today we will begin with one of the important arrangements of the object, which we call as pulley and block systems. So what is it generally called as pulley and block system? Okay. So blocks can be connected by a rope or a string, and the rope or the string will be moving across the pulley. So that is basic concept of these pulley and block systems. Here also we'll have various ways in which we can connect, but the fundamental assumptions are that the pulley will be massless as well as frictionless. Okay, and string, we have been using that standard assumption. What is it? String will be massless. So if you look at this one, right, this is what we generally call as the hanging blocks. So on one side you'll have one block, other side you have the other block. Okay, so for these hanging blocks, if you look at it, right, both of them are connected by that rope, and already we discussed during that assumptions, if the pulley is massless, no friction between the pulley and the rope, and the rope is massless, right, what do we have? Tension everywhere in the rope will be same, even though the rope is moving across the pulley. Okay, so normally when the rope is massless means tension everywhere is same, but when it is moving across the pulley, right, there is a different situation. But here we are going with the plain assumption. What is it? The pulley is massless and also there is no friction between the pulley and the rope, which means tension everywhere will be same. So the tension force acting on the block M1 will be numerically same as the tension force acting on the block M2, because this is the same rope. Okay, on both sides we have the same rope. Now look at it, how these blocks are going to move. It's a very common observation. So when you have a pulley, you connect two masses. What do you observe? The heavier one will go down, lighter one will go up. So for a minute, let us say this M2 is the heavier one. M2 will be going down and M1 is going to go up. Since they both are connected by a rope, remember we have been saying that ropes are what? Inextensible. Which means since they both are connected by the rope, their acceleration is going to be what? Numerically same. Which means if the block M2 is going down with an acceleration A, M1 also has to go up with the same acceleration A. Okay, so that is what we have seen as the connected bodies. Since the rope is inextensible, they will be having the same acceleration magnitude. Okay, now how are we going to find out these accelerations? Usually what will be asked is in this, right, they will either ask us to find the acceleration or they can ask us to find the tension force. So what we'll do is we'll start with the free body diagrams, FBD for the M1. So look at M1. M1 will have its weight which is acting down, and since it is connected to the rope, there will be a tension force into the rope, so which happens to be the up. Because of both these forces, how is this M1 moving? M1 is actually moving up, means net force upwards is what? Net force upward means upward force minus downward force, which is T minus M1G is equal to mass of that object, which is M1, into the upward acceleration. Keep it as equation 1. Now we'll go to the free body diagram for the M2. What about the M2? M2 is going down with acceleration A. So it will have its weight M2G downwards. And look at it, this is also connected to the same rope. So tension here also will be into the rope. Into the rope means what? Here it is the upward. Because of both the force it is going down, right? Means what? Net force downwards. Means what? Downward force minus upward force. This is equal to what? Mass of the object into its acceleration. So what is the equation 2? M2G minus T is equal to M2 into A. So we have two equations. What are the unknowns? Two unknowns. One is A value and other is the T value. So we can find out. So how do we find out? Just think about it. I'll erase some of it so that we can use the space. So first thing is getting these equations. Once we get the equations right, we will be able to easily solve for whatever the unknown variables. So here you check it. How we can get the variables here? A is one variable and T is the other. So how we can get it? Think about adding both the equations. If you add both the equations, right? Add the equations, equation 1 plus equation 2. Here in the LHS we have T minus T, they will cancel. So what you have? M2G minus M1G is equal to what? Right side, what is it? M2A plus M1A. Left side, M2 minus M1 into G. We take G common out. Right side, what is it? M2 plus M1 into A. So we are looking for the A value, right? Means we will bring this M2 plus M1 to the left side. It will go to the denominator. M2 minus M1 by M2 plus M1 into G. That is what is the acceleration. So once you look at the result, right, you will see something. M2 is the heavier mass, that is on one side. In this case it is in which side? Right side. M1 is the lighter mass which is on the left side. So if you look at the acceleration formula, right, what is it? The right side mass which is M2 minus left side mass M1 divided by total mass that is moving, which is what? M2 plus M1 into G. So this is what is the common acceleration. So this is what we will generally refer to as what? The acceleration of the system. What do we refer to? We will refer to it as what? Acceleration of the system. Okay. Now once you get the A value, you can take the A, substitute. You can either substitute in the equation 1 or equation 2. By substituting we will get the tension value. Okay. So that is the method to solve this. So here this kind of systems, what do we call them as? We will call them as the hanging blocks. Okay. Now we look at a question. So look at this one. It's as it is, whatever we did in that exercise, right? Same we are going to do with some numbers. In the system shown in the figure, pulley is smooth. So the regular assumptions. String is massless, inextensible. Find the acceleration of the system A. Means we are supposed to find what? A value. So here they are saying, take the value of small g as what? 10 meter per second square. Either we do all the things, or we'll just already we got the formula, right? What is the formula? Check it up, students. What will be the answer for this? It is what? You check which is the heavier mass here. 2 kg is the heavier mass, right? Means what? 2 minus 1. Look at it. What is the relation we have? M2 minus M1 by M2 plus M1 whole multiplied by G. This is the acceleration of the system, right? So 2 minus 1 by 2 plus 1 into G. 2 minus 1 means what? 1. 2 plus 1 means 3. So what is it? G by 3 means what? The 2 kg is going to go down with an acceleration of G by 3. So here what is G value? They are asking us to take 10, right? Means it will go down with an acceleration of 10 by 3 meter per second square. The 1 kg is going to go up with how much acceleration? Same value but upwards. Okay, so this is how we can solve. So we have to be clear on how do we get those equations, and it will be worth to remember this acceleration formula. What is it? For the pulley, we look at what is the mass on one side and what is the mass on the other side. So acceleration across the pulley, like that we will say. Acceleration across the pulley will be what? The heavier mass. Right side is heavier means we will do what? Right side mass minus left side mass. Heavier mass minus the other side mass divided by total mass on both the sides. M2 plus M1 into G. Okay, so this is how we will get the acceleration of the system. We've done that calculation. That's what we are repeating. Okay. So check it, students. What must be the answer? The answer should be what? It should be how much it is. It is basically 10 by 3 meter per second square. So the 2 kg will go down with that acceleration. 1 kg will go up with that same acceleration. Okay. Now we'll move on to slightly different question. So sometimes they can modify. So we have seen just the blocks hanging on either side of the pulley, right? Sometimes they can just modify. So look at this one. Two unequal masses 1 kg 2 kg are connected by an inextensible light string passing over the smooth pulley. All these standard assumptions. In fact, it is the same like what we have seen in the previous, but there is a difference. What is the difference? A force F which is equal to 20 newtons is applied on the 1 kg block. Means look at it. So we are applying a downward force of how much? 20 newtons on that 1 kg block. Find the acceleration of either block. So here also we can see both these are connected by the rope, which means what? They will be having the same acceleration. So here we'll have a doubt. In this case, should we assume like the 2 kg is still going down and 1 kg is going up, or should we take the reverse way? Because we'll have a feeling that okay, this side we are applying a 20 newton force. What is going to happen? So when you have this ambiguity, right, what you can do is assume the blocks are moving in one way. If your assumption is wrong, what is going to happen? We are going to get whatever the acceleration final you will get, right, it will be coming as negative. That's it. Means the system is going to move with the same numerical value but opposite direction. So here you can assume that 2 kg is going down, 1 kg is going up, or you can assume that since we have a feeling that okay, there that side we are also applying a force of 20 newtons, let us assume that the 1 kg is going down with an acceleration A. Means 2 kg will be going up with the same value acceleration. Okay, and the tension, both of them will experience tension. Okay, so now here also they are asking us take G is equal to what? 10 meter per second square. This is a slightly different one. So here what we'll do, let us draw the free body diagrams of M1. M1 means I am taking it as what? 1 kg. Okay, 1 kg block. So look at the 1 kg block free body diagram. It will have its weight. What is the weight? 1 into G is what? 10, means 10 newtons. Also there is a force that we applied, right? What is it? 20 newtons. And there will be the tension which is acting up. Okay, so because of this, how is it moving? It is moving downwards with acceleration A. It is moving downwards with acceleration A, right? Means what? The net downward force means what? 10 plus 20 is what? 30 minus upward force. So net downward force means what? Downward minus upward only, right? Is equal to what? Mass of that object 1 into the acceleration A. Means what? 30 minus T is equal to A. Let us keep it as what? Equation 1. Now we'll go to the free body diagram of the M2, which is our 2 kg block. 2 kg block, it will have its weight 2 kg. G value is what? 10. So we'll take it as what? 20 newtons. And there will be tension. Because of this, this is going up with acceleration A. Means what? Net upward force. Upward force minus downward force is equal to what? Mass of that object, which is the 2 into the upward acceleration, which is A. So look at it, what we have? T minus 20. This is our equation 2. T minus 20 is equal to A. Now what they are asking us to find the acceleration, right? So you can check it here also. How we can find the value of acceleration? If you think about adding both the equations, right? Now once we are able to get the equations, this is now more like math. There is no more physics. Okay, so we'll have variables we have to solve. It is like linear equations. Look at it. So if you add both of them like the same way we did, 1 plus 2 you do. There is a minus T and plus T cancel. So left hand side you'll have what? 30 minus 20. Right hand side you'll have what? A plus 2A means 3A. So what is it? 10 is equal to 3A. So we'll get A is equal to what? 10 by 3. Interesting, isn't it? So here also the acceleration of these blocks is what? 10 by 3. But there is a difference from the previous value. What is it? In the previous case, when this force F is not there, right? 2 kg was going down, 1 kg was going up. Now 1 kg is going down with how much acceleration? 10 by 3 meter per second square. 2 kg is going up with that same value of acceleration. Okay, so this is how we can have slight modifications. Like the regular ones we know, like if you have just 2 blocks on either side, means what? The acceleration of that system formula is what? m2 minus m1 by m2 plus m1 into g. Like that we will be able to conclude. But here what is it? We have some slight difference. Okay, so is it clear? So this is how we will proceed with these kind of arrangements. Okay, now we will move on to the next kind of systems that can be thought of. So here it's more like you can make different kind of permutations and combinations. There is no limit. So look at it, all the assumptions will be as it is. So we have a pulley will be massless and it will be smooth. There is no friction between the pulley and that rope. Okay, and the rope will be what? Massless, inextensible, unless they specifically mention that, okay, consider the mass of the rope like that. Okay, now what is the situation here? On the left side we have only one block, but look at the right side. We have a block m2 that is connected to, so let us call it as what? There is a rope 1. Rope 1 is connecting m1 and m2, but to m2 using another rope we are attaching a third mass m3. In fact, if you want a little bit complicated, right, we can keep on that left side also, we can attach one more mass. It can go on, we can put 2 masses, 3 masses, we can put any number of masses, but you will see here we are going to get the acceleration. So in these kind of questions, again they can ask us to find the acceleration. Or here there are 2 ropes, right? Let us say tension in the rope 1 is T1, tension in the rope 2 is what? T2. They can even ask us what are the values of T1 and T2. That can also be asked. So what are the possible things that can be asked from here? They can ask us to find what is that common acceleration value, or they can ask us to find the T1 and T2. Okay, so here also same understanding. What is it? We see, if you think of it like you are sitting on that pulley, so left side you will see a mass hanging, right side also you will see not one mass, but you will see 2 blocks connected one to other, they are hanging. So here we'll have to assume, right? So if, say for example, since there are 2 masses, let us consider that side will be the heavier one. So let us assume that the right side masses are going down. It means what? The m2 and m3, they both will go down with the same acceleration. Why? I will tell you. m2 and m3 are connected by a rope, right? Rope 2 is connecting both of them, means whatever the acceleration with which m3 is going down, m2 also will go down with the same acceleration. And since m2 and m1 are connected by the rope 1, the m1 acceleration and m2 acceleration magnitude wise will be same. Means what? Since the right side it is going down, means left side it has to go up. So m1 will be going up with the same numerical value of acceleration. That is why we said what? The acceleration of the blocks, common acceleration, they all will have the same acceleration. There are 2 ropes, there can be different tensions. Rope 1, let us say tension is T1. Rope 2, let us say tension is T2. They can ask us to find the tension values also. That is also possible. Okay. So here our task is to find, let us say, the first acceleration value, let us assume. So what we'll do, we'll draw the free body diagram for the m1. m1, what will be the force acting? Its weight, and there will be tension T1. Rope 1, right? Because of both of them, it is what is the motion? It is going up with acceleration A, means net upward force minus downward force is equal to what? Mass of that object into acceleration. Keep it as what? Equation 1. Now we'll go to the free body diagram for the m2. Where is m2? m2 is here, right? So look at this m2. m2 will have its weight. m2g will be acting on it. There will be weight, and it is connected to 2 ropes. So tension because of rope 1 will be up. Tension because of rope 2 will be down, because you look at it, right? So because of rope 2 tension is down, rope 1 tension will be up. Okay, so because of these forces, it is going down with acceleration. It means what? Net downward force. Downward, there are two forces, T2 and M2G. Downward force minus upward force, that is equal to what? Mass of the object into its downward acceleration. Now we'll go through the case of the M3, free body diagram for M3. So to solve these questions, right, we will be requiring a little bit more patience. So M3 means what? It will have its weight, and you look at it now. So there will be a tension T2 only, but it will be acting upwards. Always remember, tension on any object, right, will be acting into the rope. Because of both these forces, this is also going down, means net downward force M3G minus T2 is equal to what? M3 into A, downward force minus upward force. Okay, so this is our equation 3. Now if we want to calculate, now that we have got the equations, right, I'll just erase the free body diagrams, because the free body diagrams will actually help us. They'll be helping us to get these equations. Once we get the equations, means we can just erase this, and then we'll go into the solving. I think I have just erased that equation 3 a little bit, so I'll anyway write it down. So what is that equation 3? It is M3G minus T2 is equal to M3A. Okay, so this is the equation 3. Now just like the way we did before, right, think about adding all these 3 equations. Think about now 1 plus 2 plus 3. If you add, what is going to happen? Look at the LHS. No, this is the LHS. Here this is the LHS. Here this is the LHS. Here you have T1 and there is minus T1. T2 minus T2. Okay, so here we'll have M3G plus M2G minus M1G. Okay, is equal to RHS is what? M1A, M2A, M3A, means what? M3A plus M2A plus M1A. So here if you see, what is going to happen? M3 plus M2 minus M1 into G is equal to M3 plus M2 plus M1 into A. So we are looking for A, means we will bring this to the left side. What is it? M3 plus M2 minus M1 divided by M3 plus M2 plus M1 into G is equal to what? A. So you see, there is something interesting. What is it? Just like the way we discussed before, right? In the case of just the 2 blocks, what is it that you will see here also? M3 plus M2 means what? The total mass on the right side. From that we are subtracting numerator. Look at the numerator. From that we are subtracting M1, means the mass on the left side. So it is like what? The higher across the pulley, you will have 2 sides, right? You look at now which side the mass is higher, total mass. The higher mass minus the lower mass. So M3 plus M2 is what? The mass on the right side, which we are assuming to be higher. That is why we assume that M3 and M2 are going down. So M3 plus M2 minus M1 divided by total mass, M3 plus M2 plus M1 into G. That will be the common acceleration. Okay, so you get the idea how it is coming. So this result, if you take it and then substitute it in the equations, because as I said, right, we can be even asked to find what is the T1 value and T2 value. So how we can get the T1 and T2? If we take these equations, go and substitute in equation 1 or equation 2 or equation 3, we can get what? T1 and T2 values. Okay, now I just want to extend this idea a little bit. So look at it now. You have a pulley. This side you have what? Let's say this side you have M1. To that M2 is connected. This side will have M3 and M4. As I said, I can just keep on adding. So this is the right side of the pulley. This is the left side. Let us assume that the right side is a higher one. Total mass, we will assume what? M3 plus M4 is higher than M2 plus M1. In that case, I'm not doing the entire calculation here. We can probably do it and check. But now I'll write down what will be the common acceleration. Look at what is that right side total mass, m3 plus m4, right? Minus left side is what? m1 plus m2. We have to subtract. Divided by what is the total mass? m1 plus m2 plus m3 plus m4 whole into g. That is what is the common acceleration going to be. So we are just extending the idea. Whatever the idea we got by solving this, right, we are just taking it one more step. Like this way we can add. Why only 2? This side we can have 3, that side we can have 3, this side we can, we can have any number of masses being added like that, connected one to other. Okay, so this is a kind of model that we can expect. Now in this, look at it. We'll take a look at one similar type of question. See, I'm trying to explain first how do we approach the respective model, then we are going to the problem. The idea is first you should have an idea of how do we approach, then we can really test with the numbers. So here it is as it is what we saw in the system shown in the figure. The pulley is smooth, everything is standard assumptions, string is massless, inextensible. Find the acceleration of the system A, tension T1 and T2. So here rope 1 tension, they are putting it as what? T1. Rope 2 tension is what? T2. They are even asking us what is the T1 and T2 values. They are even asking us what is the T1 and T2 values. Straight away, since just now only we did it. Do you guys remember what is that common acceleration formula? Look at this right side of that pulley. What is the total mass? 4 plus 6, 10, which is higher than 2. Means what? 6 plus 4 minus 2. Remember that formula? m3 plus m2 minus m1 divided by into g. This is the formula, right? So 6 plus 4 is what? 10. 10 minus 2 is what? 8. Denominator is what? 6 plus 4, 10. 10 plus 2 is 12 into g. So 4 2s are 4 3s are. G we have to take it as 10, right? So 2 into 10 by 3, that is equal to what? 20 by 3 meter per second square. Straight away we are able to get what is that acceleration. What is the formula we are using? Remember, this is m1, m2, m3 means just now only we did that, right? What is that common acceleration formula? m3 plus m2 minus m1 by m3 plus m2 plus m1 whole into g. That is the formula we have got, right? Now this is only like half the work because we still need to find T1 and T2. Now let us not try to remember these equations and all that, because in JEE mains or even JEE advanced, right, we will not be able to expect exactly like, okay, this is the kind of an arrangement that will come. We are trying to solve some arrangement so that we get the familiarity. So tomorrow they will give us a different arrangement, right? We will be able to use these ideas and go and solve that type of question. Okay, so now we got the A value, right? So we are looking to get T1 and T2 values also. I'll give some time so that you can probably try and get what is the value of T1 and T2. So how do we get the T1 and T2? Because right now what we did is straight away we have used that acceleration formula that we have got. Like that we don't have the formulas derived for tensions, right? So I'll erase this part so that we can use the space. We have got the acceleration by using that ready-made formula, but like that we don't have the formulas for the tension. Then how are we going to approach? We will have to go to the respective objects. We look at the free body diagram. So if you look at M3, that's 6 kg, right? Look at the 6 kg. On this it will have its weight. What is it? G will take it as 10, right? So 60 newtons, that is the weight. And it will experience a tension T2 upwards. Because of both of them, it is going down with an acceleration how much? Just now only we got it, right? What is it? 20 by 3. It is going down with an acceleration of 20 by 3. Now what is the equation motion for this? Net downward force means 60 minus T2. Downward force is 60, upward force is T2. 60 minus T2 is equal to what? Mass of that object is 6 into acceleration is what? 20 by 3. 3 ones are 2, 3 twos are. So 60 minus T2 is equal to what? 2 into 20 is 40. So we'll take the T2 that side, bring 40 here. 60 minus 40 is equal to T2. So what is T2 value? 20. Everything is in SI unit, right? So T2 will be in what? Newtons. So we get it. T2 is equal to what? 20 newtons. So once we get the acceleration, like this, we have to go to the respective object, draw the diagram, and then we will be able to find out what are these values of tensions. Okay. Now we'll look at the 2 kg block. Why I am picking, a 6 kg block and 2 kg block, because in the 6 kg block and 2 kg block, only one tension force is involved. I know that straight away I'll get only one equation which I can easily solve. If you are going for the study of the 4 kg block, right? 4 kg is having what? Both the tensions acting on it. So you will not be able to straight away get one of the tension forces. That is the reason why, in fact, you should have asked me before itself that why are we choosing? Because once we have the acceleration, right, we can look at the motion of the 2 kg or 4 kg or 6 kg. From each of them we will get equations. But first I went for what? 6 kg. Why? Because I know 6 kg, only one tension force will be coming in that equation. Now I'll go for the 2 kg, because 2 kg also has got only one tension force acting on it. What is it? T1 up. Already I got T2. Now I'm going to get the T1. Look at this. On 2 kg there will be weight acting on it. What is that weight? 2 into 10, which is 20 newtons. Because of both the forces, how is it moving? It is moving up with an acceleration of A, which is what? 20 by 3. Now what is the equation? Net upward force, means upward force is T1 minus downward force is 20, is equal to what? Mass of that block. What is the mass of the block? 2 into the upward acceleration. What is the upward acceleration? 20 by 3. Upward acceleration is 20 by 3. Okay, so now we will be able to see. So 2 into 20 by 3 means what? It is 40 by 3. So T1 minus 20 we will take to the RHS. It will become what? Plus 20 is equal to what? 40 by 3 plus 20, which is equal to what? If you take an LCM, means it will be 100 by 3. Take an LCM means it will be what? 100 by 3. So that is what is the T1 value. So we can just note it down. So T1 will be equal to what? 100 by 3 Newton. T1 is equal to what? It will be 100 by 3 Newton. Okay. So this is how we look at the tensions. So check it, students. You also have to check it whether you are able to get these answers or not. Okay. Now what I'm going to do is sometimes, in the examination we might feel like we want to check whether the answers we got are correct or not. Now what is the checkpoint? We have seen the equation for the 2 kg. From there we got the T1 value. Equation for the 6 kg we got the T2 value. If you want to check whether these values are correct or not, we have to check by going to what? By going to the 4 kg block. So we'll just do the checkpoint now. So how we can check? Because we got the T1 value by looking at the motion of 2 kg. We got the T2 value by looking at the motion of 6 kg. So we have to check it. So we can check it by using the equation of motion for the 4 kg. So look at the 4 kg. On 4 kg, it will have its weight, which is what? 40 newtons down. And also remember, 4 kg, that tension will be at below rope will be pulling it down, right? So tension will be down. So T2 will be downwards. What is the T2 value? 20 newtons. But the rope one will be pulling it up. Always the tension will be into the rope. So T1, what is the T1 value? 100 by 3, that is up. As a result of it, this is going down with how much acceleration? 20 by 3. Now look at it. What must be the equation? The net downward force means what? Downward force Downward we have 40 and 20, totally 60, minus upward force. 60 minus 100 by 3. This should be equal to mass of the object, which is 4, into acceleration. So look at this. We have to check whether this is correct or not. Left hand side is this one. Left hand side is what? Net force. Right hand side is what? Mass into acceleration. Look at the left hand side. 360s are what? 180. 180 minus 100 by 3. That is equal to what? 80 by 3. That is the LHS. Look at the RHS. 4 into 20 by 3 means what? That is also 80 by 3. So we are seeing that LHS part is RHS, which means what? The values that we have got are actually in fact correct ones. So like that we can also check whether the values we are getting are correct or not by looking at the motion of the 4 kg. Okay, but when it comes to competitive examination like JEE, mains or advanced, right, we have to be getting the answer in one shot. So we should probably not be resorting to the check, because obviously the check point will come when we are having some buffer time, and that will be very rare. Okay, so we'll have to make sure that while doing in the first step itself, we'll be able to make sure that we don't make any mistakes in terms of these multiplication division, because in this, right, the another danger will be that instead of, like, say you have multiplied by 3, we just make it as divided by 3 like that. So then there is a chance that we'll go completely wrong. Because those kind of things we have to be careful. Okay guys, so this is how we are going to approach a problem like this. Now this is another important one. So previously what we were having only one pulley, but here you see there is a pulley connected to that, there is another pulley. So these kind of problems are actually called as cascading pulley systems. What do we call them as? Cascading pulley systems. Cascading means what? Like one coming below, like that. What do you call it as? Cascading pulleys. Okay. Now, how we will be able to solve this cascading pulley problems? So here, there is a very straightforward way of solving these cascading pulley problems without really going and writing down all these equations. We don't need to again write down the equations one by one. Remember, if you have just one pulley, this side a mass m2, that side a mass m1. If, say for example, m2 is higher, the acceleration of the objects when they move across the pulley, what is the formula for the acceleration? m2 minus m1 by m2 plus m1 whole multiplied by g. This is what we have seen, right? Higher side mass minus lower side divided by total mass into g. This value already we have derived. Using this result, we can solve these kind of cascading problems easily. Okay, so this is a very important model of question. So how are we going to approach these cascading problems? The way we'll approach the cascading problems is, we will look at the acceleration across each pulley. The rope will be moving across each pulley, right? So we'll look at what is the acceleration across each pulley, and from the top we'll usually keep coming down one by one. From the top of the pulley we'll keep coming down. That's the reason why we call it as what? Cascading, one below other. So imagine we are sitting on this top pulley. Left side, what is the mass that we see? 1 kg. Right side, what is the mass that we see? Because right side, 2 kg is also right side, 3 kg also right side. When you're sitting on the top of that first pulley, right, you're here, you see left side there is a mass of 1 kg. Right side, what is the total mass? 2 kg plus 3 kg, which is 5 kg. So acceleration across the first pulley, what is the formula? Same. Right side, what is the total mass? 2 plus 3, 5. So 5 minus 1 by 5 plus 1 into g, which is what? 4 by 6 into g, that is 2 by 3 g. That's it. So across that first pulley, what is the acceleration? 2 by 3 g means what? The rope that is moving across this first pulley, right? This side the rope will be going up with how much acceleration? 2 by 3 g. This side the rope is going to go down with how much acceleration? 2 by 3 g. So straight away we are able to tell one answer. The acceleration of 1 kg. What is the acceleration of the 1 kg? 2 by 3 into g, that's it. Because 1 kg is over. 1 kg is just going to go up with how much acceleration? 2 by 3 into g. Now our job at the top pulley is over. We will come to that second pulley. Now let us come and sit on the second pulley. So that's the approach. When you come and sit on the second pulley, you will be seeing the motion of this rope. The second rope will be moving across the second pulley, right? Now on the second pulley, you see left side, what is the mass? You have 3 kg. Right side, what is the mass? You have 2 kg. So how is it going to move? 3 kg will be going down, 2 kg will be going up. Correct or not? So acceleration across the second pulley means how the rope will move across second pulley. What is that? One side you have 3, other side you have 2. So 3 minus 2 by 3 plus 2 into g. That is what? 3 minus 2 means 1. 1 by 5 into g, that is g by 5. Okay, so now let's erase this part and show you how it is going to look like. So you see here the rope that is moving across the second pulley, right? How is it? Moving. It is moving in such a way that this rope we are talking about the second rope. This rope is moving in such a way that the 3 kg is going down with how much acceleration? G by 5. 2 kg is going up with g by 5. Now when we want to talk about the total acceleration of the 3 kg block, remember 3 kg block is having 2 accelerations coming, one from the movement of the ropes across the first pulley and other acceleration coming from the movement of the ropes across the second pulley. So overall acceleration of 3 kg, it's like what? Acceleration coming from 2 sources. Overall acceleration means what? Resultant. Look at this. Because of the movement of the rope across the first pulley, the entire right side setup is going down with how much acceleration? How much acceleration is going down? 2 by 3 into g, right? Means what? The acceleration coming is what? 2 by 3 into g, because of the motion across the first pulley. And because of motion across second pulley, what is it? G by 5. Both are in downward direction. You can check. This is also down, this is also down. So overall acceleration of 3 kg will be what? 2 by 3 into g, that is downwards, plus g by 5, that is also downwards. Both are downwards. So both are downwards means we can just add them, right? What is it? Take an LCM, 15. So 10g plus 3g, what is it? 13g by 15. Overall will be what? Downwards. Overall will be what? Downwards. Okay. Now we look at the acceleration of the 2 kg. Remember, for 2 kg, there is an acceleration coming because of the rope movement across the first pulley. What is it? 2 by 3 into g, down. But because of the movement of the rope across the second pulley, what is the acceleration coming? G by 5, upwards. So there is a difference between the two. What is it? One acceleration is down, other acceleration component is what? Up. So when you want to look at what is the total acceleration, right? So we have to check which of them is higher. The acceleration is a vector, right? Which is the higher one? 2 by 3 means what? The factor is 0.67. 1 by 5 means 0.2. Which is higher? The 2 by 3 factor is actually higher. So the net acceleration will be what? 2 by 3 into g minus g by 5. Why are we doing subtraction? Because we are dealing with vectors here. Downward value is higher, upward value is lesser. So we are doing what? Downward minus upward. We are looking at the resultant. Okay. So what is it? 2 by 3 into g minus g by 5. Take an LCM. What is the LCM of 3 and 5? 15, right? So here also we will get denominator 15. Okay. So 10g minus, what is it? 3g. How much it is? 7g by 15. Net acceleration will be what? Here, no, the higher is what? Downwards, right? So net acceleration will be downwards. So look at this, the 2 kg will have what? Net acceleration 7g by 15 down. What about the 3 kg? 13g by 15 down. Only that 1 kg block is having acceleration upwards, which is 2 by 3 into g. Okay students, so this is how we will solve the cascading problems. What are we doing basically? One by one. We are moving from the top of that pulley, one by one we are coming down. So across the first pulley we will see how the acceleration is happening. So we look at what is the total left side mass, total right side mass. Acceleration will be what? The higher one, whichever is higher mass minus lower mass by total mass into g. That is the formula, right? Like that we keep coming down one by one pulley. The movement of the rope across any pulley will give the accelerations. When we want to find the total acceleration, means what we have to do? We have to carefully add them by looking at the directions. In case of 3 kg block, what is happening? Both the accelerations coming for the 3 kg block are down. That's why we are able to simply add them. But in case of 2 kg block, what is happening? The acceleration coming due to the movement of the rope across the first pulley, right? What is it? 2 by 3 g down. But the second acceleration part is g by 5 up. We are seeing whichever is higher. Which is higher one? The 2 by 3 into g is the higher one. That is the reason why we are doing what? They are in opposite directions. So higher minus lower we will do. The net acceleration will be in the direction of the higher one, which is downward direction here. Okay. So like that we have to proceed and solve these kind of questions. What do we call them as? We will call them as the cascading type of questions. Okay. This is an important one, especially for the JEE mains type of examination. Okay. Now we'll go into the next one. So this is like we can have one block. The block M1 is kept on that horizontal table. Here our assumption will be what? We are talking about the smooth. The table and the surface of the block are smooth. Other block M2 is hanging. So what is the common understanding we'll have? This M2 is hanging, so it will go down. As a result, the M1 will be moving towards the right side. So here we can be asked questions on what is that acceleration, what is the tension. Here also, if the pulley is massless and there is no friction, means since a string, we are going with the standard assumptions. What are those? String is inextensible and string will be massless. So tension everywhere will be same. These are the standard assumptions. If there is any change, means we have to be careful. So look at this. First we will draw the free body diagram of this hanging block M2. So what is it? It will have its weight M2 into G and there is a tension T. Because of both of them, it is going down with acceleration A. Means what? Net force downwards M2G minus T, because the downward force is M2G, upward force is T. So net force downward means what? Downward force minus upward force. So M2G minus T is equal to what? M2 into A. Let us keep it as what? Equation 1. Now we look at the motion of the block M1. Block M1 is moving horizontally, right? We will not bother about the vertical equation. Why? Because we know vertically there is no motion. If you write the vertical force balance, means we will get only the normal reaction between the block M1 and the table. That is not needed here. That will be required only when we talk about the friction. So here horizontal direction, there is only one force, which is tension T, because of which it is going in the direction of that force with an acceleration A. Means what? That force, only one force is there. T is equal to what? M1 into A. This is our equation 2. Horizontal direction, for the M1 there is only one force acting, that is T, because of which it is having an acceleration A. Means what? T is equal to M1 into A. That's it. Two equations. Now here as I said, we can be asked to find the acceleration or tension. Just look at it. Do like the way we have been doing, right? Equation 1 plus equation 2. Here minus T and plus T, LHS cancel. So LHS is what? M2G. RHS will have what? M2A plus M1A, which is what? M2 plus M1 into A. So we are looking for acceleration, means what is the acceleration value? We will bring that M2 plus M1 to the, so I'll erase this equation because we already got it. So we'll have to bring this M2 plus M1 to the left side. So what is it that we are going to have? Check it. we will have what? If you bring this to the left side means it will go to the denominator. So m2 by m2 plus m1 whole multiplied by g, that is our acceleration. Once we get the acceleration, right, we can take the acceleration, substitute in any equation. Maybe this is the simplest one. Equation 2 is simplest one. Straight away we will get the t value. From that we can get the t value straight away. Okay. So this is how we are going to approach these kind of questions. Okay. Is it clear, students? So what we'll do is we'll just take a look at a sample question as it is. The only thing is here we have given some numbers, that's it. Okay, so what is it? Same, right? In the system shown in the figure, all the surfaces are smooth, string is massless, inextensible, all the standard assumptions. Find the acceleration A of the system and the tension T in the string. What are we supposed to find? We are supposed to find what is the acceleration of the system and the tension T in the string. So either we would remember that formula just now that we did. What is it? So if you don't remember the formula, then we can just go ahead and then quickly write the equations again, because once you have the familiarity, right, to some extent you will be able to remember the formulae. After some time we are going to look at these problems again and we will see how we can get the answers quickly. Like there is a concept called as net force method. So what is the concept called as net force method? So we'll see how we can solve these, whatever the problems we are writing all the equations and then doing it, right? We can solve these questions in a simple manner without making so many steps by using the concept called as what? Net force method. So once we go through all the examples in detail, right, then we will be looking at how we can solve all the problems easily by using the net force method. Then you may think, sir, why are we learning this detailed approach now? Because the detailed approach is the core. Only when you know this, right, you will be able to understand how that net force method is coming. Okay, so look at it. So here maybe we can just so this is like our m2, this is like the m1, right? So we already have the formula for acceleration. What is it? m2 by m2 plus m1 into g. I hope you guys remember this. Just now only we did, right? What is it? m2 by m2 plus m1 into g. Okay, that is the acceleration. Means what? m2 is what? That hanging block we call as m2. So 4 by 4 plus 2 into g. What is it? 4 by 6 into g. What is g value? 10, right? So we'll put it 4 by 6 into 10. That is what? 2 2s are 2 3s are 20 by 3 meter per second square. So check it, students. What is that acceleration A value? 20 by 3 meter per second square. Okay, so that should be the acceleration. So 4 kg will be going down with this much acceleration and the 2 kg will be going towards the right side. 4 kg will go down and 2 kg will go to the right side. Okay. Now it's not over, because they are also asking us what is the tension, right? Remember we have this equation. So we'll just go back and see that, right? So we have the equation. What is it? T is equal to m1 into A. So means what? for the 2 kg block, if you look at the equation, T is equal to what? Mass of this, which is 2 into A. A is what? 20 by 3. That is equal to how much? 40 by 3 newtons. That's it. So what is the tension force? It is what? 40 by 3 newtons. Is it clear? So this is how we are going to approach when you have this kind of an arrangement. So as you see, right, what is happening from the arrangement to arrangement, the way these blocks are connected is changing. But the core idea is what? Always we are writing down the free body diagram, looking at what are the forces acting, and then we are deciding what is the direction of motion for the system. Like always we are assuming what? It will move in a direction. Like in this case, what we did, 4 kg is the hanging one. So usually what is it? The hanging one, we will pull it down, right? So we assume 4 kg is going to go down. Since they both are connected by a rope, which is inextensible, the 2 kg will be moving towards the right side with the same acceleration value. Okay, so that is the assumptions we have made, and then we are going with the using of the Newton's law, which is, we'll find the net force in a direction is equal to what? Mass of the object times acceleration of the object in that particular direction. So this is the approach that we are taking. Like for each and every problem, it is the same approach. Okay, so keep practicing, guys. In the next session, right, we'll start solving some more types of arrangements before we go and discuss about the friction, because all these problems, right, we are dealing with smooth surfaces. We have not talked about the friction. So in next session, we'll cover some more models of these arrangements. Then we'll talk about the idea of frictional force. How do we study the friction, and then how we'll solve these problems when there is a friction. So all these models, right, again, each and every problem that we have seen now, they can be solved by including friction. Okay, so we'll see how these problems can be solved when we have friction force between the surfaces. Okay, so we'll see in the next session. But before that, right, you can start practicing some questions on whatever the model that we covered so far. Okay, we'll see in the next session.